In this video, I'd like to talk about the math question of the day for January 25th, 2023. And with this problem, we need to solve for the variable x in this rational equation. And to solve this, you essentially will need an understanding of Algebra 1 and Algebra 2. So you have to have some familiarity with solving these rational equations and essentially what to look for. And at this point, go ahead and pause the video, see if you can solve this on your own. Spend at least a couple minutes going through this, even if you're not sure what to do. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted this problem, we can go through this together. And as always, if you have any suggestions for future questions of the day, please feel free to suggest those in the comments. Now, with rational equations, we have the variable x in the numerator and in the denominator. So the main strategy is to get x out of the denominator. But before we do that, we need to remember that we cannot divide by 0. That is undefined, meaning that if we plugged in -2 or +4, notice that we would end up dividing by 0 in both of these cases. So we can immediately eliminate these two values since these values of x would lead to undefined scenarios. So x can't be -2 or 4, but from there we can just use algebra to solve this. And like I mentioned, we need to get x out of the denominator. So let's start with this left-hand side. And to cancel out division, this denominator here, we can use multiplication. In fact, if we multiply by whatever that denominator is, then these will cancel out since something divided by itself is always equal to 1. And of course, we will do that on both sides of our equation. But let's cancel out this denominator as well. We can also multiply both sides of the equation by x minus 4. That will cancel this out on the right side. So on the left, let me just make a little bit more room here. We have x minus 4 multiplying through. And carrying out this distribution, notice on the left, the x plus 2 in the top and in the bottom cancel out, so that we get this x minus 4 multiplied by 3x minus 3 if we actually distribute here. And on the right-hand side, notice that the x minus 4s will cancel out, so that we get 2 multiplied by x plus 2, which we can rewrite as 2x plus 4. And let's further simplify. We can distribute and actually multiply these out. So the x goes to both, the minus 4 goes to both. We get 3x squared minus 3x. Then we do minus 4 times 3x, which is minus 12x, and minus 4 and minus 3 would give us positive 12. This is equal to 2x plus 4. And since we have a quadratic, we will move all of the x terms to one side of the equation. So let me just make a little bit more room here. Let's subtract 2x and 4 on each side of the equation. We get 3x squared, and this is minus 15x minus 2x, so that's minus 17x. This becomes a plus 8. This is equal to 0. And from here, we can try to factor this, or we can just use the quadratic formula. And when the coefficient on x is not 1, it's usually not factorable unless it was constructed to be factorable. So in my opinion, it's better to just use the quadratic formula so that you don't waste time if it's not factorable. And remember, the quadratic formula says that x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And this is for a general quadratic. Ax squared plus bx plus c is equal to 0. And we can see that our a value is 3, b is negative 17, and c is 8. So let's plug everything into our formula. See if we can simplify. We have x is the opposite of b, so that's positive 17. And we need to square 17, or negative 17, but in both cases it becomes a positive number. And then we will subtract 4 times by a times by c, and all of this is over twice a, or 6. And simplifying everything, 17 squared, that is 289. And this product here would be 96. We're going to be subtracting that. So we get 17 plus or minus the square root of 289 minus 96, which is 193. All of this is over 6. So it looks like our two solutions are when we have the positive and negative version of this expression. We have 17 plus root 193, which is irrational, so we can't simplify that. All divided by 6, and we have 17 minus root 193 over 6. And of course, if we wanted to check these, this would be very tedious, but we could check these by just plugging back in for x and making sure that everything simplifies.